So here we go, people. What are we trying to do? Prove. Oh my gosh, you love that word. We're trying to prove this limit with an epsilon delta proof, but first we need a definition. Let f be a function defined on an open interval that contains the number a, except possibly at a itself. Then we say the limit of f of x as x approaches a is L, and we write the limit as x approaches a of f of x is L. And here's the good part. If for every epsilon bigger than 0 there exists a number delta bigger than 0 such that if the absolute value of x minus a is smaller than delta, then the absolute value of the function minus the limit is smaller than epsilon. And now that we have that definition, we need a game plan. So we need a game plan, and here's what we're first going to do. We're first going to identify our x minus a, and then we're going to evaluate the function minus the limit until we get some constant times whatever we had in part 1. Why? So that we can choose our delta. We can choose our delta to be an epsilon over c. Excellent. And then we're going to summarize it, and this is the proof part. We're going to start off with if this, then that. Some steps will be in here, a few of them, and we'll show that it is smaller than epsilon. Okay, ready? Here we go. Step 1. I need to identify my x minus my a. And on this nice linear example, a first example, look for another one. A more harder one. I'm taping it again today too. Okay, ready? Okay, sure. So then this is the absolute value of x minus, wait for it, 4 is it? That's my a. So I'm looking for that. In part 2, I'm going to evaluate this limit, or this function, minus this limit. So then in part 2, my function is the thing that I'm taking the limit of. I'm looking for f of x minus L. And then this is a 2x minus 5, wait for it, minus 3. Because that was my limit. And like Sports Chalet, we'll take you to the limit. Now here we go. This is the absolute value of 2x minus 8. Great. And the reason our first step said identify this, now we need to massage and manipulate that absolute value in order to get what we were looking for. So you see here, say, we can factor out a 2, say, and we do it indeed get an x minus 4. Now, the absolute value of a product is the product of the absolute values, and I can write the absolute value of 2 times the absolute value of x minus 4. Sure, finish him. We have just gotten that part. That part where we got what we were looking for times some number. Clean that up. The absolute value of 2 is 2 times x minus 4. Now that gets us our c. And what does that get us, c? It gets us part 3. In part 3, we're going to choose delta to be equal to epsilon over that c right there, say 2. Oh. And now it's time to summarize. Over here, in part 4. Now this is where we make a summary. What do we state? We first start if the absolute value of x minus my a 4 is smaller than delta, then consider what? The function minus the limit. Why? Because we're trying to do an epsilon delta proof. So we're going to consider f of x minus L. Yes, well, in our scratch work we had taken a look at this, and we said that this is the absolute value of 2x minus 5 minus that 3. And we absolutely want to write this step in. The next part, you can say that this is equal to steps omitted, 2 times the absolute value you should include your scratch work in your proof, but just call it scratch. X minus 4. Sure. Now notice what we've done. We said if this is smaller than that, then we considered this. But wait a minute, this is smaller than delta. So then this looks like it's going to be 2 times, whoa, that's not equal to. If this is smaller than delta, then this is smaller than 2 times delta due to inequalities. But what was our choice of deltas? Our choice of deltas was to let delta be epsilon over 2. So now we have 2 times epsilon over 2. Divide! And we've done what we set out to do. If this is smaller than that, then we've shown that the limit minus the function minus the limit is smaller than epsilon. It has been shown. Some people like to do that. I like to do this. Box and flower.
This one time in math class. Real stories from the classroom.